All right, so we're going to show you today Lab 11. So that is the conservation of momentum. So to do that, we're using the air track once again. This time we're going to have two gliders, okay, because we're showing a collision essentially. So we're going to do an inelastic collision first. So if you remember from inelastic collisions, it is when two objects collide and they stick together and then move off together as one object. All right, so we're going to start before the collision. Before the collision, they're not stuck together, they're separated. All right, so we have cart A here with the flag on it, and this is going to be the cart that's moving, and it's going to collide with cart B. And B is going to initially be stationary. It's going to have zero velocity initially. Okay, so when I move cart A, he's going to have a certain momentum, because momentum is mass times velocity. If he's moving, he has a momentum. So to calculate the velocity of cart A, once I have him in motion, it's going to go through this first timer. And this little flag on top is a certain distance. This timer is going to record how long it took for that flag, that distance, to get through the timer. So if you have the distance and you have the time it took, you can calculate the velocity using distance divided by the time. Okay, so you can get the velocity of cart A just from those two data points, the distance and the time. Okay, so I have cart A moving through the timer. He then collides with cart B, who is initially stationary. He transfers then his momentum. They move off together because it's an inelastic collision, so they're stuck together, and they're going to go through the second gate. And this same flag of a certain distance is going to go through this gate, and we'll record the time there so that we can figure out the velocity after the collision, which will be the distance divided by the time. Okay, so let's see this in action with the air track on. See what it's going to look like. So we're going to have this cart stationary, and I'm going to get that cart A in motion. So let me unplug this. All right. There we go. All right, so I'm going to hold cart B stationary while I get cart A in motion. Okay. Once he hits, they move off together, and I get the final velocity with that gate. All right, so now that was inelastic. They stuck together, they moved off together with one final velocity. Now I'm going to switch these around so that it's going to now be an elastic equation. So with an elastic equation, what's going to happen is when they collide, they're not going to stick together and move off together. They're going to bounce off of each other and go, and this one is going to go its separate way. So what we're seeing here is a transfer of momentum. Okay, so we're going to have cart B stationary once again at the beginning. We are going to then move cart A. Cart A is going to go through the first timer so we can get its velocity before the collision using that distance and that time. Once cart A hits cart B, it's going to come to a stop because its momentum, its mass times its velocity, is going to then be transferred to cart B, causing cart A to stop and cart B to start moving with that momentum that was transferred. Cart B is going to continue moving through gate 2, and we can figure out cart B's velocity after the collision by taking the distance divided by the time that the timer gives us. So, turn the air track on and you can see the concept here. So, cart B is going to be initially at rest with a velocity of 0. I'm going to move cart A so that it hits cart B. Cart A stops while cart B moves forward, transferring its momentum.